So, yeah, we're still solving inequalities. So just like always, it's progressively getting more complicated. So I could have made the linear inequalities like really long and like drug out, right? So we could have distribution on the left side, distribution on the right side, distribute, and like all the big long equations. But inequalities are interesting. We can have multiple inequalities happening at one time, so that's where we get compound inequalities. Does anybody know what compound means?
More than one.
Okay, so compound means more than one. Let me write that down. What about like in English class? What does compound mean?
Two things put
Okay.
together.
And I want to say you have like compound sentences. Right, two sentences put together and they're combined by what kind of words?
And one or the
Right? I mean, there's more options than that. You have and, but, or you could do like however and or and yeah. Many different ones. These are the ones you learn like right away in grade school. 3 compound words. In math class, we were working strictly with and strictly with or. So there's no but inequality that we have. Today we're working strictly with and. So and would represent the inequality. Okay, sorry. I like lost how I wanted to say this. I'm going to say it has to be true for both. So basically, we're going to get out like a solution. So our solution has to be true in the first inequality and the second inequality. Okay, has to satisfy both of them. Or I'm going to say the solution has to satisfy one of the inequalities. So with or, it can only be one or the other. It can't be both at the same time. If it's both at the same time, we fall into the and one. Okay, so only can be true for one or the other. So with and, we're doing that today. Tomorrow's with or. So I'm gonna explain how we get two inequalities in one. With and, I think it's kind of interesting, but you know I'm a math teacher, so yeah. Okay. So we're going to write a compound inequality. We're going to write it together so it's going to look kind of weird. So what is one inequality I can write down? If you hear it. Okay, right, so that's all the numbers greater than 2. So that's writing the symbols. We have this lovely word and, which tells me it's an and inequality. So I'm going to actually write the word into it. Yeah, so it says less than 3, so we reuse all real numbers is less than 3. So we have x less than 3. You can see very well because we're going to see problem. So this would be nice. I could leave it like this, but and we could be more creative than that. So on the left, when I could flip it around, right, that's legal in math, I can rewrite this. When I switch it, then the inequality switched with it. And I can write and with it. But we even want to take it a step further. I can shove it all together. Right, so I can eliminate this word and have -2 less than or equal to x for my left one. Instead of writing x again, I could just write the symbol less than 3. So this is how you technically write and inequalities. So a couple things to know when it's in this form. Step number 1 has to go least to greatest. All right, so basically it's telling -2 is on the left side of +3, which is larger. Step number 2, the symbol is always less than or less than or equal to. So you never see an and inequality with a greater than symbol. They're always both the same, and they're both less than or less than -2. It is more interesting because we can write it like that, or you can never put them together, unfortunately. Okay, so that's writing it. They said to graph it. So same thing how we graph. We have -2, we have 0, we have 3. So at -2, do we have a circle or a dot? And then a circle. So if I just look at -2, am I shading to the left side of -2 or the right side of -2? Gotcha, good. Yeah, so we should be looking at this one.
X.
Yeah, the X has to be on the left side for you to use the whole inequality arrow situation. So this is shading to the right. What about at 3?
The other one. Left.
Okay, left. And it has to satisfy both inequalities, so I have to figure out where the shaded region is overlapping. I want to say in this class, 90% of the time we're shading in the middle, because that's where my inequalities overlap each other. Okay. Moving on. So we have 2 different conditions. So water is liquid when the temperature is greater than 32 degrees Fahrenheit and less than 212 degrees Fahrenheit. So let's write a compound inequality. Okay. Right, this is how writing it all in one long line, I could push it together.
So 32 is less than X. And less than 212.
Yeah. So our least degree is 35 is smaller than 212. Both my sides are less than. So that's good. Here is this one. A refrigerator is designed to work on an electric line varying from 415 volts to 120 volts.
Would be X. Is greater than 115. X is less than.
Right, we want to be larger than 115, less than 140, because we're between those two values. And we can write it together.
115 is less than X. Less.
Okay, so those aren't too bad. So now we're going to solve them with compound inequalities. Okay, so this is, we're still solving them the exact same way. We have 2 like inequality symbols. So when we do a specific operation in the middle to get x by itself, I have to do it on both sides of the inequality. So if I'm looking at 2x plus 3, how do I get x by itself first? Yeah, I need to subtract 3. If I subtract 3 in the middle, I have to subtract 3 on the right side, and I have to subtract 3 on the left side. I have to do all sides of this inequality.
It is less than or equal to 2x.
Okay, same thing with moving the 2. Yep, divide by 2, but it has to be on the right side and the left side.
-4 is less than or equal to X.
2. And we can graph it on the number line. So on -4, circle or dot? Dot. 2 is, and where am I shading? In the middle. Right, it's smaller than 2, larger than -4.
We're really not shaded in the middle.
I feel like it would have to be a more complicated problem.
So we probably won't have it.
No. No. In like algebra 2 you do, but in algebra 1 not really. With 4 you could do with 4. multiple ways, it's easier to like make that one more interesting. So yeah. This is probably always in the middle. Make that assumption. Always be right. Okay, you're doing this one by yourself. And then we have one more after this, which is fun. Doing great. Okay. So, crushed it. Anybody see what's different about this one then? Or should we start? Okay. Yeah, these are like flip flopped around. Okay.
You're gonna have to divide by a negative, so it's gonna flip the signs.
Yeah, so we have a negative in front of our x value, so that's a little interesting. So we're going to divide by -2 on all sides. So then what do I have?
Then you got 1 is greater than x. Greater than or equal to negative 8. You have to flip it because.
Yeah, but I thought it had to be less than.
Right, it has to go least to greatest. 1 is larger than -3, so it's not. So I need to like flip the whole thing over.
Negative 3.
So
negative 3 is less than or equal to x less than 1.
Right. So even like the inequality signs flipped and the signs flipped, the numbers flipped, and it's just like a lot of flipping. Okay. And then you drop it to end the problem. -3 has a circular dot. And
You
one
want to put 0 on your line?
you should. Yeah. I mean, if you don't, it's not a big deal, but I like to see that you know that one is on the right side of 0.
I guess the back.
Hi. Yeah. Yeah.